Hi everyone, welcome to Data Platform Virtual Summit 2022. Yes, it's virtual, not live. I remember how at last year's summit said I hope that this year we would be able to do it live. Unfortunately, we're not. However, with the platform used, the experience is almost like real life. You can go to the exhibitors' booths, visit the booths between sessions, go to the attendee lounges and connect with the fellow attendees. So even though this session is recorded, I will be around when the session is presented for the Q&A. In that regard, it is almost like live. So if you have any questions, don't hesitate to ask. Also, at the end of the slide deck, I have my email address. So email me if you have any questions that you can't ask during the Q&A. Now, let's get started. So this session is ksqlDB, the real-time streaming database. So we will have a look at ksqlDB and see what it is and what we can do with it. I'm Niels Berglund. I am software architect lead at Derivco in Durban, South Africa. At Derivco, we are doing an iGaming platform, the world's leading iGaming platform. So the agenda for today is that we will start with an introduction to Kafka, the Kafka 101. What is it? What do we do with it, etc. Then we go on and look at stream processing. Why are we using stream processing? What are the benefits of stream processing? The majority of the time we will then look at ksqlDB, the real-time stream processing database. And we'll talk about streams, talk about tables, and we'll talk about queries. All right, so Kafka 101. So Kafka started back 2010-ish at LinkedIn. They wanted it to replace their messaging systems. Kafka was a success at LinkedIn, so they open sourced it in 2014. Confluent is the commercial arm of Kafka, and they are providing support, etc., etc. So what is Kafka? It's a distributing streaming platform. It's not really a messaging system per se, even though you can use it for messaging, obviously, but it is a streaming platform. And what do I mean with that? Well, you are publishing and you are consuming streams of records or events. Well, we can call it messages as well if we want, but let's call it records. We can persist, or actually, the records are persisted by default, which is good. And then by doing it, by persisting these records, we also have the ability to process streams of these records in real time. Kafka is built upon a commit log. And as database people, we like logs because they are trusted, right? They are trustworthy, and we can also distribute them for scale and resilience. So let's have a look at the ecosystem of Kafka and some components. So let's start with the ecosystem. So obviously we have Kafka, or what we call a broker. So this is the main part, this is the central part of the Kafka ecosystem. We have Kafka Connect, which allows us to connect to sources and publish to Kafka, where Kafka is a sink, or we can read data from Kafka. Kafka is a source, and we can send it to other sources such as databases. We have K-streams. K-streams is a stream library written in Java where you can write applications that are now consuming these messages, these events, the records that are published to Kafka. Then we have the star of the show, ksqlDB, which is once again, it's a real-time streaming database. It's built upon K-streams. We'll talk more about that in a bit. We have schema registry, which allows you to have strongly typed events, strongly typed records. Control center is a web UI for Kafka, so you don't have to use a console if you don't wish. And Control Center is enterprise, the enterprise version only. Then finally we have a REST API, so we can we can do requests, get and posts to Kafka to execute stuff. So that's kind of the ecosystem. Then we have components. So when we're talking about Kafka, we're typically talking about a cluster. So that's a cluster of brokers, a cluster of nodes. A cluster, when we say cluster, we quite often think of multiple servers, multiple nodes. That is not the case here. You can have a cluster of one broker, and it is still a cluster. In a production environment, you would have a lot more, obviously, but a cluster can be one broker. You have the broker, which is where you are sending events to, and you are sending events to topics. So see the broker as for you database people out there, see the broker as a database. And the topic is where we are sending the events, the records to, and that is like a table. Then, as in databases, we can partition these. In a database, we can partition a table. In Kafka, we partition topics. We have offsets. So, as I said before, the Kafka is essentially, it is a commit log. So records events are being published into this log and is available from an offset. So you're reading a message from offset 0, you're reading a message from offset whatever. Finally, consumer groups is the way that we are consuming from Kafka, from topics. And I'll mention that briefly in a little bit. So, topics and partitions. A topic is the name, the definition of a stream of records. We can call it wager, we can call it login, we can call it order, etc. The topic can have a schema, or rather the records that we publish can have a schema. It can be JSON, it can be Avro, it can be CSV or protocol buffers. When we are publishing a record, we are passing in three things, or three things goes with the message. It's a key, it's the value of the record, and a timestamp. The timestamp, if you don't define a timestamp explicitly, Kafka itself will assign it a timestamp. Then for a topic, you have different properties. We can have a retention period. How long will records stay in this topic? How do we compress it? How many partitions will we have on the topic? And the replication factor, to how many nodes are we replicating this particular record? So that's kind of the basis of topics. So the topic consists of partitions, and the partition is the actual log. And by having partition, we can now scale out Kafka, because we can put these partitions can now sit on different nodes if you so wish. And the partition also provides order, because the publisher controls the partitioning in the way that the publisher assigns a key to the record, to the event, to the message. And then in the library, in the client library that publishes, so this is kind of internal Kafka stuff. In that library, the client is hashing the key. It's consistent hashing, and then based upon a modulus of the number of partitions, the client decides which partition to send the record event message to. And that's how we are now getting order, because messages, so based upon the key, we are always getting the records in order. Right. Cool. So how are we publishing and consuming here? So on the left-hand side here we have a producer which has it's an application that using a Kafka client. Most applications are using the Confluent client libraries, but there are also other libraries out there. And the library, you have libraries for most of the popular languages. So Java, obviously, as Kafka is written in Java, C#, Python, Go, what have you. The publisher now writes to the topic. So this whole thing here is a topic, right? And the producer, as I said before, and the producer is deciding, is calculating now which partition to write the message to. If you write it to there, if you write it to there, if you write it to there, based upon the key in the record in the event. And then that record, that event will now end up on a partition in an offset of that particular partition. Right. Then on the right-hand side here, we have consumers. These are applications. And the thing with the consumers is that I said they belong to a consumer group. And to ensure scalability, to ensure order, we are saying that one partition can only be read by one particular consumer group. So as you can see here, we have 3 consumer group A's, and they are all reading from different partitions of this topic. However, so you may now say, well, what about throughput in this case? You can have, however, you can have other consumer groups reading from the same partitions. And as when we are reading, we are not reading off the message. The message stays in the partition until its retention period. So consumer group A and consumer group B can both read exactly the same message. Right. So let's do some coding, shall we? So what we want to do is we want to publish and consume to Kafka. But before we do that, let's have a look at the web UI, the Kafka web UI, as I said before, the control center. Right. So just as some explanation here, I'm running Kafka in Docker on my local host. You can obviously run Kafka on-prem. You can also run Kafka in the cloud through Confluent Cloud, which is a managed Kafka service. That is very, very, very cool. We are starting to use it at Eurivco now, and we have great hopes for that. Right. Anyway, so we to the left here, we have sort of a menu. We get an overview. Right now we have over here we're having 52 topics in total, and they are all internal Kafka topics. So let's go into topics. And we have here, we see one existing Kafka topic that has to do with ksql, but let's create a topic here. So we'll be clicking here on add topic, and we give it a name. And since I'm in the iGaming industry, let's call it gameplay. Right. You can see here how we can define how many partitions, etc., etc., etc. Right now we are happy with just one partition. So create with defaults, and let's go back to topics, and we can now see here how we have one topic, gameplay, right? So now to publish and consume, for that, we are using Python. Well, actually, I'm using Python here. I am normally a .NET dude, but I kind of like Python. I'm not an expert in any shape or form, so I'm probably doing a lot of wrong stuff here, but well, it works on my machine, or at least it used to work on my machine. So let's see if the demo gods are with me. So I have two Python files here, and run gameplay Kafka, right? So the idea here is that we are going to we are emulating gameplay. That may be in a casino, that may be some other type of games, whatever, where we have an event, a gameplay event that has a player ID, it has a game ID, we have a score, and we have a win. So the score is kind of how much you are putting in, and the win is obviously how much you're winning, if anything. And then we're having the time that this happened. I have a method here, generate gameplay, where I'm basically randomizing the player ID, game ID, score, event time, what have you, what have you, what have you. And up here we have we have the some variables, constants that I'm using in the randomizing. What is the minimum player ID, maximum player ID, minimum game ID, etc., etc., etc. Right, cool. So when we are running this, so we can see here some code to, we are setting up a configuration variable where we are saying, okay, where is my Kafka cluster? Right. Bootstrap.servers, that indicates where my Kafka cluster is, and that is on localhost port 1992. And then I'm also sending in a client ID just for the fun of it. We are now creating over here. A producer where we say producer configuration. Then what we are doing is we are saying generate and publish. We are generate a gameplay event, and we are producing to my topic with a key and a value. Right? And eventually, well, down here we are now looping through everything and publishing. Cool. I also have a consumer, as I said, which is doing more or less the same thing. I'm having a configuration over here. I'm creating a consumer. I'm saying that I want to listen to this topic, and then we are going into a polling situation, a polling scenario, where we are polling off, well, where we are reading the event in the topic. Cool. So let's run this, shall we? Let's make sure that everything is saved properly. And then what we do is we we are having some consoles. That one we can get rid of. And here we are doing Python run gameplay Kafka Pi. We are hitting that. We are ready. Press enter to continue. Actually, let's do here and start up the consumer as well. Cool. So we have now started the consumer, and we are starting the publisher. And we can now see how we are getting messages produced and messages consumed. That is very, very cool. We have now published messages to the topic, and we have read the messages from the topic. Cool. Let's get out of this one. We can keep the consumer running for now. What we also can do is we can go into Control Center, to my gameplay topic, go to messages, start looking at offset 0, and we should now see the messages here. Essentially the messages that we published and we consumed. Right. Cool. So then let's continue our journey in Kafka land. So now we have seen how we can publish and consume. And as I said, so this was now Python code. We could use C#, we could use Java, we could use C++ if we really wanted to feel the pain, Go, Rust, what have you. All right, so stream processing. So now we have pushed in data to topics in Kafka. What do we do then? Well, stream processing is what we do when we want to handle events. So now events comes into Kafka, and now we want to do stuff with them. And we are quite often using stream processing in real-time and user-facing analytics scenarios. And we can see here down here in my little diagram how here we have a producer who is pushing in red, blue, purple, and green boxes, right? And then, so he is, let's see if we can do it this way. So he publishes into here. This is now a Kafka topic, right? And in here, we now have the stream processing person that looks at these boxes and pushes them to wherever they should be. Yeah? Cool. So, and a couple of scenarios here for user-facing and real-time analytics, where we have on the left-hand side here, we have, you probably have seen, well, you are probably on LinkedIn and you have this thing, who viewed your profile, right? That is, we can more or less in real time see who viewed your profile, or in this case, my profile. And yeah, what do I say? I don't have that many viewers on my profile, but anyway, and this is more or less in real time, right? Or we have, coming back to what I am doing, we have a leaderboard where this is some sort of game, and we then have people here. That was a bad color for my, but anyway, where we now have people here that sits on the leaderboard and has a score, has some values, and we can see who they are, etc., etc. Right. So with this in mind, let's do a scenario here. So we're in my world. We are spinning on some sort of slot machine, right? We are now pulling the handle. That now generates a game event. That's what we saw before, right? That's what I published now in my Python code. And how the game event has, here we have player ID, game ID, win, score, and event time, yeah? Exactly as we saw in the Python code. That is published into Kafka, into a topic in Kafka. And now we want to do a leaderboard based upon that. How do we do that? What do we do? Or at least we want to create the basis for a leaderboard. Right? The leaderboard is defined as accumulated win, where the score is greater than whatever, and win is greater than 0. Because it doesn't really make sense to accumulate wins if the win is 0. Right. Cool. If you were now told to do that, how would you do it? Well, you could roll your own using the Kafka consumer. You could take your C#, your Python, whatever, and start consuming these messages coming into the topic. The problem comes in immediately. How do we handle state? Right? So remember, here we're now doing an aggregation. So when user Niels is playing the game, we need to know how much was his accumulated value before and how much is it after, etc., etc. Right? So that is, you can do it, but it will be a lot of pain. For that reason, K-streams was introduced. K-streams was introduced in 2016, and that is a Java library where we can build streaming applications. And these streaming applications takes an input and is doing an output, and you can, in between the input and output, you can now transform the messages, do stuff with the messages. The downside with K-streams is that it is Scala or Java only, right? And it is hard. Well, it is programming. It is hardcore programming, as hardcore as Scala and Java can be, obviously. So based upon that, a year later, ksql was introduced, and that is built on top of K-streams. And it has a SQL syntax. No Scala, no Java. It is good old SQL that most, at least database developers, are used to. There are some caveats. There are some, oh God, why can't you do this? Why can't you do that? But it is cool. It is awesome. Right. So after ksqlDB came. It's an evolution of ksql introduced in 2019, and it is now a true SQL layer for working with data in Kafka. We are reading from Kafka and we are writing back to Kafka. And this now allows you to build stream processing application. So here we can write real-time applications using SQL, no Java, no Scala. If you want to do something fancy, you still have the ability to write Java and Scala code and implement that as a user-defined function. And this definitely lowers the bar for implementing streaming. Right, so here we have a source stream. It comes into a topic. We have on the right-hand side, we have ksqlDB. ksqlDB now reads from the topic, and then it processes the message, and then it writes back to the topic, to another topic. That can now in turn be handled by ksqlDB, more processing, etc., etc., and be written back to a topic if we so wish, or we can now output this to applications for analysis, BI, machine learning, leaderboards, for example. Right. So when we're talking about ksqlDB, we're talking about streams and tables, where a stream is it is a stream. Think about a stream in the nature. Water is just running and running and running and running and running, right? So it's an unbounded sequence of events. We can't do any changes to this. The event comes and it goes. We can't change it. It is what it is. A table, on the other hand, is a view of a stream or another table. And this is now mutable. So you now have the ability to change data in this table. And when we're talking about streams and tables, we're talking about the stream and table duality, where we can turn a stream into a table using DML manipulations, or we can turn a table into a stream by capturing the inserts, updates, and deletes. So that's when you read documentation around ksqlDB, you will often read about the stream and table duality. This is what it is. You can turn a stream into a table, or vice versa, you can turn a table into a stream. Right, so the syntax then for ksqlDB. It is somewhat similar to ANSI SQL. We have create, where we can create stream, we can create table, and we can create some other stuff. This create is always combined with a select or insert. So we can say create stream select from something. We have, when we are doing these streams or tables, we have support for windowing functions. So we have session window, we have hopping window, we have tumbling window. We can do inserts, and then we have freestanding selects, which I'll talk about a little bit later. And there are other stuff. There is quite a few functions, built-in functions, scalar, aggregation, table-based functions, what have you. So it is very much a fully fledged SQL language. Right, let's go off and do some coding again, shall we? Right, so now we have here, we saw how we were producing data and how we were reading off data. Now what we want to do is we now want to create the basis of a leaderboard. So what we want to do is we want to take the data coming into this topic, gameplay I think it was called, and do stuff with it. And for that, as I said before, we are using ksql. When we look at the web UI, we have the ability here at the web UI to go into ksqlDB here, and we coming into an editor, right? And we can see how we have streams and how we have tables, etc. here. And we can definitely write our queries here. So you have the ability to write ksql queries using this web UI, but I would strongly suggest that if you are doing something more than just select star from, which even didn't work for me, you will be using the ksql CLI. Right, let's actually see how that works. So exit out of here, and what you do with ksql with the CLI is that you are connecting to the ksql DB server, as I have here. That works fine. That's awesome. So I have some cheat sheets over here on my right hand side. I'm now setting this offset to earliest, and so now we are into the ksql CLI. Clear out that, right? So now we are where we started. So what we want to do is we want to create a stream over here, where we're saying create stream game events. We are picking up the player ID, the game ID, the score, the win, the event time from the Kafka topic gameplay. And we're saying that JSON is the format of the data. Right, so let's do it to it. And here we go. and stream created, that is also always a good sign, right? So now we can do select star from whatever was that name, stream game events. Stream game events, emit changes, and now we see here how we are getting data. So these are now the 5 first messages, events that we sent through in here that was also consumed here by the consumer, right? Um, the what was I going to say? So I set the reset to earliest, which means that this now started reading from the beginning. Normally, the default value is latest. So until I were to, so if I had left it as it was, we wouldn't have seen anything in here until I had started producing messages again. So actually, so let's change this query a little bit. Oops, wrong one. What is that? Player ID, score and win. Let's just do something. Select player ID, score, win from stream game events is what I think it was called. And then we're saying emit changes. I'll come back to in a little bit saying what this emit changes, what that means. For now, let's just assume that it needs to be there, which it does, right? And now we're getting my player ID, my score, and my win as per before. Right, so what now, if we are then lucky, and once again the demo gods are with us, we can run this gameplay again and see what happens. And here we can now see both how we, over here in my ksql query, and over here we are actually receiving messages. So we have now created our first ksql stream. So when you now want to work with stream processing in ksqlDB, the first thing you need to do is either to create a stream or a table over your topic. It's probably 9 times out of 10 you are creating a stream. So now we have my stream. Now then, what can we do? Let's exit out of there. Let's exit out of there. Clear that out. That's cool. And now what we're doing. So now what we want to do is to create a table over my data. All right. So what we are doing, because this is now the basis for the leaderboard. And I'll talk you through what I'm doing. So I'm copying my cheat sheet over here. So now we're creating a table here called tb underscore ag underscore ag score. TB for table. I'm an old SQL Server guy. So when I create tables, everything starts with TB underscore something. So here now TB ag stands for aggregated and score, where an interesting part of this is that I'm saying Kafka topic. Right? I have not created a Kafka topic. If we're going back to topics, I'm only have my gameplay topic here, right? So I'm now saying that the output, the result from this should be written to a topic called agscore. One partition and value format is JSON again. And what we're doing is we are selecting a player ID. We're then doing something weird where we're saying as value player ID as player ID val. I'll talk about that in a second. We are doing a sum of the win as aggregated win, and we are saying from stream game events where score is greater than 100 and win is greater than 0. And we are grouping it by this player ID. Right. Remember when I actually, so this is how we created my stream, where we said that player ID is the key. Player ID is has the key value, and that's somewhat like primary key in a SQL Server table. Right? The thing is, if I want to, here I'm using now my player ID. That's just fine, but I want to push it to a Kafka topic, ksqlDB, and when I read out from the topic, this key is not part of the value of the message. It is pure, you will only get sort of the value portion, which now would then be the aggregated win. So that's why we're doing a little bit of a hackety hack, and we're saying as value, player ID. So we're saying treat this as a value, not as a key, and we give it an alias player ID val. Right. So let's see if this now works. Group by player ID, that looks good. Have I forgotten any commas? No, I don't think so. Let's run that. Whoa, that worked. So we now have a query here, TB ag score. We have a table, called TB ag score, which we then can do select star from TB ag score, meet changes. Right, running that, and we're now having player ID val, and ag win. So we see that player ID 100 has an aggregated win of 262. Player ID 104 has an aggregated win of 404. Right. So you may now ask yourself, why do I see player ID here? What did I say about this player ID val? So this is when we are reading it out from the table, but the table is now backed by a topic. Right? So actually, if I were to do this, if I said something like that, we're clearing out, and then I'm saying print, the topic was, what was it called? Ag score, hey? Ag score. And let's see if that works. Right. So this is now, we are printing out the topic, what is in the broker, what is in the log file. And we see clearly here we have a key of 100, and then we now have my player ID val 100 and agwin. We see nowhere in the topic player ID, if that makes sense. Right. Cool. Let's clear this out again. And now then, so let's run this query. Actually, let's do a change here and set this to latest. call. Clear out. And now let's change a little bit here in in the configuration. So let's say that we want to do 50. We want to generate 50 events. Right? So we change that to 50. And now let's run my gameplay again. And we should see how eventually, well, maybe I should do a select here first. So now we're waiting here for changes to that underlying table. And we see player ID, val, agwin, right? So let's start with running the gameplay. And here we are. And now we are getting, we see on the left-hand side how we are producing messages, on the right-hand side how we are consuming off the original topic, and here how we are now on the selecting from the table, right? But we are selecting as the data comes in, and we can clearly see how for a particular player ID, how the value, the aggregated win, how the aggregated win changes. Right? So now we have created the basis for a leaderboard. We could now push this into a database table in order to get the right order, etc. Because at the moment in ksqlDB you still don't have an order by clause. Right. So we don't want that anymore, I don't think. Let's go back to the slides. So this we have seen. Right. So push and pull queries. Right. So we have seen both of these scenarios. Well, actually, we haven't seen the latest one, so we'll have a look at that. So a push query, when you're reading about ksqlDB and you're looking at select statements, we're talking about push queries and we're talking about pull queries, where a push query generates a continuous stream of updates. Right? Whereas a pull query gets the current value and terminates. So if we were to go back to this one, I think it was, yeah. Let's do select star from, what was that table called? TB ag score, star from TB ag score. I mean, we have done this. We have done the changes already. So where player ID equals 104. Yeah, that is now a string. For some reason, I created it as a string. That wasn't probably the smartest thing I did. And here we now have my 104. I have an aggregated win of 880. Right. There we go. So, and the push query is, once again, we are pushing the query to Kafka to ksqlDB, and we are getting a continuous stream of data coming out. So, to sum it up, Kafka is a distributed streaming platform. Stream processing is where we are handling the events, the records that arrives in Kafka. If we now want to do stream processing without having to write a lot of complicated code, we can use ksqlDB. ksqlDB has an ANSI-like syntax, SQL syntax, sorry. We are talking about tables, we're talking about streams. A stream is immutable. A table is mutable, as we have seen. And we're talking about the table and stream duality, where we can create a stream from a table. We can create a table from a stream. All right. Thank you. And the questions are now for the Q&A session that is immediately now. And once again, here is my contact details. So take note of that. If you have any questions that you can't ask now, please email me. Then, thank you, Microsoft, for doing this. This is awesome. They are the diamond sponsor. They have a lot of, by their support, the data platform geeks and the SQL Server geeks can do this. And a huge thank you to the organizer here, data platform geeks and SQL Server geeks. They have done an awesome job. So thank you. Right, you have the ability to win prizes. Post your selfie with hashtag. Oh wow, I didn't know that. Please give feedback. Give feedback on the session. Give feedback on the conference. Visit sponsors and exhibitors. And once again, well, follow the Data Geeks Data AI Summit on Twitter. Thank you and bye.